Do you know that the phone in your hand, the battery you charge every day, came from places where the water is black like oil and the land can no longer grow anything? Much of the rare earth that keeps modern technology running has passed through toxic sludge ponds, where people breathe metal dust instead of clean air. Your technology looks polished on this side of the world, but on the other side, it begins with a sacrifice almost no one wants to talk about. The waste ponds come first. In Inner Mongolia, they stretch for kilometers, thick with black sludge left after rare earth processing. In northern Myanmar, acid runoff from unregulated mines seeps into farmland and streams, guarded by armed groups instead of fences. In parts of southern China, entire villages were relocated after soil tests showed levels of heavy metals too high to farm, too high to live with. These places are not hidden. They are simply far away from the people who benefit from them. Near one of these sites, a worker begins his shift before sunrise. The ore was extracted years ago. What remains is the residue. His job is not to dig, but to prevent overflow. Pumps run day and night to keep toxic slurry from spilling beyond the embankments. When they fail, the liquid sinks into the ground. There is a procedure for that. It does not involve evacuation. His children no longer drink from the local well. Water trucks arrive every few days, depending on budgets approved in offices he will never see. He understands what this place produces. The materials move on to factories that make batteries, screens, motors, and guidance systems. He has seen the shipping containers. He recognizes the names printed on the manifests. Technology companies, defense suppliers, multinationals that talk about clean energy and innovation. What never leaves this place is the damage. Respiratory illness is common. Land prices collapsed without announcements. Compensation programs exist on paper, but most families stopped applying years ago. Moving away requires money they do not have. Staying means accepting what the ground has become. This is not an accident. It is a design choice. The system works because extraction happens where resistance is weakest and consequences are easiest to contain. Distance separates consumption from cost. The farther you are from these sites, the cleaner your technology appears. The closer you live to them, the more permanent the damage becomes. Rare earths are called rare, but scarcity is not the real problem. These elements exist in many parts of the world. They are found in rocks on every continent. What makes them difficult is not extraction. It is what happens after the ore is pulled out of the ground. Raw rare earth ore is useless on its own. To become usable, it must be separated into individual elements. That process is slow, chemical-heavy, and destructive. Large volumes of acid are used to dissolve the rock. Solvents separate one element from another. Heat stabilizes the final compounds. Every step produces waste. Toxic water, heavy metals, radioactive residue. None of it disappears. This is where the paradox begins. Modern economies depend on rare earths to meet goals they publicly support. Clean energy, electric vehicles, digital infrastructure, advanced defense systems. At the same time, those same economies enforce environmental standards that make large-scale rare earth processing politically difficult and financially unattractive. Permits take years. Lawsuits follow. Cleanup obligations stretch across decades. No elected official wants a waste pond on their watch. So production does not stop. It moves. Processing shifts to places where land is cheaper, enforcement is weaker, and resistance carries fewer consequences. Pollution is not reduced. It is relocated. The environmental cost does not vanish. It is pushed outward, away from consumers and toward communities with less leverage to refuse it. This relocation creates a second problem. Countries that exported processing also exported expertise. Facilities closed. Engineers retired. Supply chains thinned. When dependence became visible, rebuilding capacity proved slow and expensive. Meanwhile, demand continued to rise. Electric vehicles scaled faster than processing plants could be permitted. Renewable energy targets arrived before waste handling solutions were in place. Defense systems assumed uninterrupted supply. Attempts to break the dependency have repeated the same pattern. Alternative materials have been tested. Performance drops. Efficiency declines. Engineers compensate by using more material, increasing weight, or shortening product lifespan. The trade-offs are measurable. None of the substitutes fully replace rare earths at scale. The dependency remains. Recycling is often presented as a solution. In practice, it recovers only a small share of what is needed. Collection systems are fragmented. Separation is complex. Contamination lowers yields. Even aggressive recycling scenarios fall short of projected demand growth. Recycling slows the problem. It does not remove it. What remains is a system built on contradiction. Governments want secure access without hosting pollution. Corporations want stable supply without long-term liability. Consumers want clean technology without confronting its origin. Each demand is rational on its own. Together, they lock the system in place. Environmental standards become local achievements rather than global ones. Pollution statistics improve inside borders while rising elsewhere. Responsibility becomes a matter of jurisdiction, not impact. When damage crosses borders, it becomes a diplomatic issue. When it stays local, it becomes someone else's problem. This is why reform stalls. Not because solutions are unknown, but because every real solution concentrates cost where political power is strongest. Moving that cost elsewhere has been easier. The paradox holds because it distributes benefits upward and consequences downward. Rare earths became strategic not because they are scarce in nature, but because the world depends on materials it refuses to process responsibly. The contradiction is not temporary. It is structural. As long as demand continues and accountability remains fragmented, the system will keep choosing distance over resolution. The system does not start at the mine. It starts earlier, inside permits, contracts, and thresholds that are adjusted quietly over time. A license is granted. An exemption is added. A deadline is extended. Each decision looks minor on its own. Together, they shape where damage is allowed to exist. Extraction is only the first visible step. Rock is broken down, or is separated. At this stage, the focus is volume. Environmental impact is recorded in reports, summarized into acceptable ranges. The real transformation happens later, far from where the material is consumed. Distance is built into the system by design. Once extracted, the ore moves. By truck. By rail. Sometimes across borders. Processing facilities are rarely located near final markets. They are placed where land is available, opposition is manageable, and enforcement can be negotiated. The farther these sites are from consumers, the less attention they attract. The system benefits from this separation. Processing is where value and damage concentrate. Ore is crushed again, dissolved in acid, filtered, heated, and separated element by element. Each pass creates waste. Acidic water, heavy metals, radioactive residue. These byproducts are not accidents. They are expected outputs of the process. Managing them is treated as a cost center, not a priority. Waste is stored in tailings ponds, injected underground, or discharged under regulatory limits. Monitoring exists, but enforcement varies. Acute spills are reported. Chronic leakage becomes background. Over time, the distinction matters less. The ground absorbs what it is exposed to repeatedly. From this point on, the system becomes clean. Refined materials move into factories that manufacture magnets, motors, batteries, and electronic components. These facilities look nothing like the sites that produce the waste. They are enclosed, controlled, and compliant. Workers wear protective gear. Audits focus on safety protocols and labor standards. Environmental damage is no longer visible. By the time rare earths reach assembly lines, their origin has been reduced to codes and certifications. Supply chains are tracked, but selectively. Documentation confirms delivery, purity, and compliance with contractual terms. It does not capture cumulative harm upstream. Downstream operators are insulated from responsibility by design. Corporate structure reinforces this insulation. Suppliers compete on price and reliability. Environmental performance is measured through checklists rather than outcomes. If one processor fails, another is contracted. Continuity matters more than correction. Contracts are short-term. Liability is long-term. The mismatch is built in. Governments participate without direct ownership. Strategic materials are discussed in policy papers. Supply security is framed as a national interest. Environmental consequences are classified as domestic issues of producing countries. When pollution crosses borders, it becomes a diplomatic concern. When it stays local, it disappears into administrative silence. Regulatory systems follow jurisdiction, not impact. Cleanup obligations are tied to legal entities that can restructure, merge, or dissolve. Environmental bonds rarely cover full remediation costs. When operators exit, responsibility shifts to local authorities. Budgets stretch. Priorities change. The waste remains. Communities closest to processing sites absorb what the system excludes. Land loses value first. Then water access degrades. Health issues appear gradually, unevenly, difficult to attribute to a single source. Proving causation requires resources residents do not have. Claims stall. Studies are commissioned. Time passes. As conditions worsen, choices narrow. Younger residents leave if they can. Older ones stay because relocation is expensive and uncertain. Compensation programs exist, but eligibility is strict and payouts lag behind damage. Property becomes unsellable. Mobility declines. Exposure becomes routine. What keeps the machine running is fragmentation. No single actor controls the whole chain. Each participant operates within acceptable limits. Each decision is defensible on paper. Profit accumulates downstream. Risk accumulates upstream. Those closest to the waste have the least leverage to change how the system operates. The machine is not hidden. It is distributed. It relies on complexity rather than secrecy. Legal separation, geographic distance, and technical specialization ensure that responsibility is never concentrated. By the time rare earths appear as finished products, the system that produced them has already faded into abstraction. Nothing in this process is illegal by default. It is optimized. Optimized for cost. Optimized for speed. Optimized to keep benefit and consequence as far apart as possible. That distance is not a side effect. It is the machine's most valuable component. As long as demand remains high and accountability remains fragmented, the machine does not need to change. It only needs to keep moving. The consequences do not appear all at once. They spread across regions, shaped by geography, regulation, and how long a place is allowed to absorb damage before attention shifts elsewhere. Each location pays a different price, but the pattern is consistent. In Inner Mongolia, the damage is concentrated. Processing facilities expanded for years alongside a growing tailings lake built to contain waste from rare earth refining. Over time, the lake grew larger than nearby towns. Tests showed elevated levels of heavy metals and radioactive elements in surrounding soil and groundwater. Farming declined first. Yields dropped. Then wells were sealed. Water delivery replaced local supply. Relocation programs were announced in stages, tied to budget cycles rather than environmental thresholds. Some families moved early. Others stayed, locked into compensation disputes that stretched for years. The lake still requires constant pumping. Full remediation remains undefined. In northern Myanmar, the pattern is unstable rather than centralized. Rare earth extraction expanded rapidly with little oversight. Small-scale operations carved hillsides apart, chasing quick returns. Acid runoff flowed directly into rivers used for irrigation and drinking. Control over access roads became a source of conflict. Armed groups taxed production. Revenue circulated locally but rarely funded infrastructure or cleanup. When international scrutiny increased, official exports slowed. Informal extraction continued. Environmental damage deepened without appearing in export data. Across parts of Africa, rare earth mining is framed as opportunity. Governments promote new projects as pathways to development and diversification. Permits are issued. Environmental assessments are completed. Processing capacity lags behind extraction. Waste management plans rely on future investments that have not yet materialized. Early contamination is treated as manageable. Long-term liability is deferred. Communities near proposed sites face familiar trade-offs. Employment arrives quickly. Environmental safeguards arrive later, if at all. In southern China, older processing regions tell a quieter story. Facilities shut down after decades of operation as regulations tightened and production shifted. The waste remained. Soil remediation programs began, then slowed. Monitoring continues, but land use restrictions persist. Property values never recovered. Younger residents left. What remains is a landscape shaped by past demand and present neglect, carrying damage that no longer serves current production. These regions differ politically, economically, and culturally. What links them is function. Each occupies a position in the same supply chain. Some host extraction, others host processing, others inherit contamination after production moves on. The damage is distributed unevenly but predictably. Environmental harm does not travel backward through the system. Once material leaves a region, the consequences do not follow it. Cleanup costs remain local. Legal responsibility fragments across operators that no longer exist or have restructured. International buyers rarely appear in remediation discussions. Their involvement ends at delivery. This distribution creates invisibility. Some sites attract attention when damage peaks or spills occur. Others remain local problems, discussed only in community meetings and health clinics. None disrupt the global flow. Demand continues. New regions are added to the map. Old ones fade from memory without recovery. The map expands without resolving its past. The system does not correct previous damage before moving on. It relocates production. It externalizes cost. It leaves behind landscapes that require management rather than restoration. Over time, exposure becomes normalized. Elevated contamination levels are treated as baseline conditions. Communities adapt downward. Expectations adjust. What would once have triggered intervention becomes routine. The absence of catastrophe is mistaken for stability. This is not a series of isolated failures. It is repetition. The same sequence replayed under different flags and regulatory frameworks. Extraction begins. Processing scales. Waste accumulates. Oversight weakens under economic pressure. When costs rise, production shifts. The damage stays anchored to place. The map does not show accidents. It shows design, a system that expands by redistributing harm rather than reducing it. Each new site inherits the lessons of previous ones, but rarely the resources to act on them. This is how the global supply chain grows while carrying unresolved damage forward. Not by repairing what it breaks, but by finding the next place willing, or forced, to absorb the cost. The village was still listed in government records long after it stopped functioning as one. On paper it existed. On the ground, it had already crossed the line where daily life became management of exposure. Fields lay unused, not because of neglect, but because soil tests taken years earlier showed contamination levels that made farming unsafe. The report circulated briefly through administrative channels, then disappeared into a larger environmental review. No closure order followed. Production upstream continued. The processing site nearby had been operating for decades. Over time, waste storage expanded outward in measured increments. Each expansion passed inspection. Each met revised thresholds. The tailings pond grew slowly enough to avoid triggering emergency response. Pumps ran continuously to control water levels. Maintenance crews focused on preventing sudden failure, not long-term seepage. Chronic leakage was assumed, monitored, and accepted. During a season of heavy rainfall, the system reached its limit. The embankments held. There was no breach. Instead, pressure forced contaminated liquid through weak points in the soil barrier. The spread was gradual. Drainage channels carried it into surrounding land. By the time sensors registered abnormal readings, dispersion had already occurred. Officials arrived days later. Samples were taken. The event was classified as contained. In the months that followed, patterns emerged without a single defining moment. Clinic visits increased. Respiratory issues became common. Skin conditions appeared across age groups. Fatigue and headaches were reported frequently. Medical staff treated symptoms. No centralized record linked cases to environmental exposure. Establishing causation required longitudinal studies that were never funded. Residents sought answers through formal channels. Complaints were filed. Meetings were held. Investigations were announced. Each step produced documentation. None produced resolution. The operating company cited compliance with existing regulations. Regulators cited lack of conclusive evidence. Environmental agencies deferred to future assessments. Responsibility moved between offices without settling anywhere. Relocation was proposed as mitigation. Eligibility depended on land valuation conducted after contamination was acknowledged. Values had already collapsed. Compensation reflected this. Appeals stalled. Legal assistance was costly. Families faced decisions with limited leverage. Accept reduced payouts and leave. Or remain on land that no longer supported agriculture or safe water access. Many stayed because relocation meant debt without guarantees. The site did not shut down. Operations slowed temporarily. Protocols were updated. Monitoring equipment was upgraded. Reporting frequency increased. None of these measures addressed what had already entered the ground. Cleanup timelines extended. Beyond decades. Funding commitments remained conditional. Responsibility blurred as contractors changed and ownership structures evolved. No headline marked collapse. There was no single incident to point to. The crisis unfolded as a sequence of administrative decisions, each defensible in isolation. Permits renewed. Thresholds adjusted. Studies delayed. Over time, harm accumulated in increments small enough to manage procedurally, but large enough to persist materially. What happened here was not unique. It was concentrated. The system rarely produces dramatic failure. It produces sustained exposure. Exposure that resists attribution. Exposure that spreads responsibility thin enough to avoid consequence. As attention shifted elsewhere, the village ceased to be discussed as a community. It became a reference in internal reports. A site number. A data point cited in future assessments to illustrate risk without altering demand. The material continued to move through the supply chain. The waste did not. This is where the system reveals its operating logic. Damage is tolerated as long as it remains localized. Human cost is acceptable as long as it cannot be aggregated into a single number. The absence of spectacle is not an oversight. It is a feature. The climax is not collapse. It is normalization. When harm becomes routine, intervention becomes optional. The system continues not because it succeeded, but because it learned how to absorb failure without stopping. The damage does not end when production slows or shifts elsewhere. It settles into the future and reshapes it quietly. Land that once supported farming becomes restricted by default. Water sources require treatment that local budgets cannot maintain indefinitely. Health effects persist without clear endpoints. These are not recorded as losses. They are adjusted for. Cleanup, when attempted, moves slower than contamination ever did. Removing waste is expensive. Isolating it is cheaper. Most sites are capped, fenced, and monitored rather than restored. Remediation plans exist on paper. Funding arrives in phases. Timelines stretch beyond political cycles. When operators restructure or exit, responsibility transfers to local governments. Environmental bonds rarely cover full costs. The gap becomes public debt. As consequences accumulate, policy language changes. Rare earths are no longer discussed primarily as environmental risks. They are reframed as strategic assets. National security enters the conversation. Supply stability becomes the priority. Environmental standards are treated as secondary constraints rather than non-negotiable limits. Emergency provisions appear. Temporary exemptions extend. Oversight adapts to urgency. International competition reinforces this shift. Governments announce plans to secure domestic supply chains. New mines are proposed. Processing facilities face resistance. Communities push back against becoming the next sacrifice zone. Permits stall. Legal challenges delay construction. Costs rise. Timelines slip. Demand does not slow. Under pressure, existing producers increase output. Thresholds are revised. Monitoring intervals stretch. The same regions absorb additional exposure to maintain global flow. Damage concentrates further where it is already established. The system prefers continuity over correction. Efforts to diversify supply introduce parallel risks. Smaller facilities lack experienced oversight. New operators replicate early-stage mistakes. Waste handling failures reappear under different regulatory frameworks. Lessons documented elsewhere arrive too late or are deemed impractical. The cycle repeats, rebranded as transition. Over time, options narrow. Once contamination crosses certain levels, reversal becomes theoretical. Once expertise disappears, rebuilding capacity takes generations. Once dependency deepens, withdrawal becomes destabilizing. The system locks itself in not by choice, but by accumulation. This is not collapse as interruption. It is collapse as constraint. The future becomes bounded by damage already absorbed. Decisions are made within a shrinking set of acceptable outcomes. Restoration is discussed. Adaptation is funded. Prevention arrives too late. Rare earth supply chains reach the stage because correction is always postponed. Cleanup is deferred. Alternatives are researched but not deployed at scale. Accountability is fragmented across borders and balance sheets. The present remains optimized at the expense of resilience. What remains after collapse is continuity without repair. Production continues. Environmental baselines shift upward. Communities adapt downward. Policy debates move on. The system survives by accepting degradation as normal operating condition. This is how structural failure presents itself in modern economies. Not as breakdown, but as endurance under worse terms. The material keeps moving. The ground keeps absorbing. The balance never resets. The story ends where it began, far from the places where technology is assembled or advertised. At the edge of a containment site, the pumps are still running. Monitoring reports are still updated. Fences are maintained. The ground absorbs what it has been trained to hold. Nothing here looks temporary. By the time rare earths reach the devices people use every day, their origin has been stripped down to numbers and certifications. Shipping codes, compliance statements, performance metrics. The waste has already been separated out, buried, diluted, left behind in places that no longer appear in supply chain diagrams or investor briefings. This separation is what allows progress to feel clean. Environmental improvements are measured locally. Emissions decline within borders. Technology becomes lighter, faster, more efficient. At the same time, damage accumulates elsewhere, outside the frame of consumption. Responsibility thins as distance grows. No single actor feels accountable for the whole. Rare earths did not reshape the world on their own. They enabled systems that require uninterrupted flow, energy transitions that cannot pause, digital infrastructure that cannot fail, military readiness that assumes constant access. Each system depends on materials whose full cost is acknowledged only in fragments. What remains after production moves on is not silence, but maintenance. Pumps, caps, monitoring schedules, land use restrictions. Communities adjust their expectations downward. What once would have been considered unacceptable becomes a baseline condition. The absence of disaster is taken as success. The waste does not stop reacting because demand stabilizes. The land does not reset because contracts expire. Exposure continues on timelines that do not align with fiscal years or election cycles. The future inherits what the present optimized away. The device in your hand feels finished. The system that produced it is not. The damage remains active. The dependency remains unresolved. Nothing about this process suggests closure. It is designed to persist as long as distance can be maintained. Progress did not arrive without cost. It learned how to move that cost out of sight.